Hi, this is a supplementary math lesson for advanced math, lesson 59B in your textbooks. I'll be working on the example starting on page 389 in your textbooks. If you want to pause the video and open it up to that page right now, go ahead and do so. So they titled this section of the lesson, "The Color of the White House." So this is Mr. Saxon's attempt at humor. It's kind of a play on the words, you know, of the old joke, "What color is the White House?" Duh, it's white, okay? Who's buried in Grant's tomb? Grant, okay? And so the whole lesson is meant through that title to represent that even though this looks, as far as a logarithmic problem, man, it looks kind of scary, it's really not. It's actually kind of a play on the logarithmic convention of writing things, just like those jokes are a play on those particular words, okay? So starting with our first example, 59.4 at the bottom of page 389. So if we want to evaluate this logarithmic expression, or that they ask you to simplify, okay, we look at that now. The logarithmic expression is in the exponential part of the problem. It's an exponent of that number 42, okay? And so what is it saying? It's saying 42 raised to what power will give me 5? Okay, 42 raised to what power? Well, I don't know, because it's a base 42 problem, okay? I don't know. I guess if I had a fancy calculator, I could figure that out. But if I don't, I'm just going to say, well, if I'm just going to replace that whole expression with x, because I don't know what the power is 42 has to be raised to equal 5. I'm just going to say let's make that whole expression x, okay? Because actually that's what the logarithmic expression equals. It equals that unknown power. I don't know what it is, okay? So my new expression becomes 42 to the power of x. Well, if I notice here, okay, taking this logarithmic expression, I've defined that as x, okay? By definition, expressing this in exponential form, how would I express it? I would express the base to that exponent, x, equals the argument in the logarithmic expression, which is 5. So 42 to the x equals 5. That's what this logarithmic expression means in exponential form, okay? Well, that's what I have expressed here. I've replaced that logarithmic expression with x. So I have 42 to the x. Well, what is it? Right over here, I've defined it according to this logarithm. It's 5. Okay? So, it's interesting to note. So it's a play on words. It's a play on logarithmic expressions, okay? So just the thing to keep in mind, anytime we have a number and a logarithmic expression in the exponent that has the same base as that number, we have the number 42 here, okay? We have the base is 42, and it's a bare bones logarithmic expression. It's the logarithm of the argument to that base, okay? That's what we have. Okay, we don't have any numbers in front of it. We don't have any logarithmic expressions added to it. It's just a bare bones logarithmic expression. If that's the case, the number here and the base up here in the exponent match, the solution is going to be that argument up there in the logarithmic expression. The solution is going to be 5. The equating it is going to be 5. It's going to be the argument, okay? So just keep that in mind. Well, that's going to be our aim to evaluate these kinds of problems. Let's go to the next example, 59.5. Okay, so they give another logarithmic expression that's in in the exponent. Okay, so what do we have? We have a number out front and the logarithmic expression in the exponent, but it's to the base 3. We would need a 3 out here to apply that, because the number being raised to the power has to be the same base as the logarithm in the exponent. Okay, we don't have that. But we notice 9 has a peculiar relationship to 3. Okay, we can change that number to a 3 squared. Okay, 9 is going to be replaced with 3 squared. Okay, our logarithmic expression in the exponent remains. Okay, now what do we have? We have a exponential number, a power being raised to a power. Okay, our rules of exponents say when we have a power raised to a power, we multiply the powers together. Okay, so we would get 2 log base 3 of that argument 5. Okay, and then of course we need to have a simple logarithmic expression with no numbers in front of it in this form up here. Okay, so we get rid of this 2 in front of the log. Okay, we do that through our logarithmic rules by sending that base 3 up into the exponent of 5. Okay, now that we have accomplished the same thing, we've got it in the same form as over here. Okay, the number out front matches the base number in the logarithmic expression in the exponent. Then the solution, the simplification, is simply the argument. This case, the argument is 5 squared. We expand that out to 25. Okay, that is our solution. So our whole aim in these is to get him down to the simplified logarithmic expression in the exponent so we can apply that kind of play on words mathematically for this type of logarithmic problem. Okay, let's go to example 59.6 on the next page, 390. Okay, we have a 10, 4 log base 10 square root of 3. Okay, this is our logarithmic expression in the exponent. Okay, we notice the number out front matches our base, but it's not the most simplified logarithmic expression. We have that 4 out front, so we're going to get rid of that 4. We're going to move it out of there. Okay, we're going to re-express that as the log base 10, the square root of 3 raised to the power of 4. Okay, now we have a radical being raised to a power, and then we notice through our rules of radicals, okay, a square root of 3 is nothing more than 3 to the 1/2 power, okay, to the 4th power. So we have a 3 to the 1/2 power being raised to the 4th power. We have a power being raised to the power. How do we deal with that? Okay, we multiply the powers together. We get 3 to the 2nd power, because 1/2 times 4 is 2. Okay, we have the number and the base match. It's in simple logarithmic form. So the answer, the simplification, the evaluation of that logarithmic expression is the argument, the 3 squared, or we expand it out to be 9. Okay, so it's the same drill no matter what. You're going to try to get it. We want the same base as the number out there. We want it in the most simplified logarithmic expression possible, just the log, okay, the log, the base, and the argument. Okay, the argument can be in a rather complicated form, okay, or it can just be a number. But once we have it in that simple form, then the solution is simply, it simplifies to the argument, okay? That big number in our logarithmic expression. So I hope that helps with this lesson set. It's really another form of advanced logarithm problems. That's why I put that up there instead of their title, the color of the White House. So that's mathematician humor for you. If you're wondering what in the world does that title have to do with anything. So I hope this helps. Shoot an email or a text message with any questions or issues. So long for now.